Unit 18, Day 2, Factoring Quadratic Equations Review. Okay, so like I said, it's review. Now, the things in this are going to be, or at least seem, rather familiar. So you got to make sure that all of this stuff is kind of making sense because we will be using this. Just like we said before, factoring is going to come back. You're going to see it. You're going to have to use it again. So in order to solve these things, these quadratics that we've been talking about, you have to be able to factor. Okay, it's going to help out immensely. So first up, we have to factor each of the difference of two squares. All right. Now, if y'all remember correctly, how these things work is we've got the minus sign in the middle and two terms. Alright, now if we have that minus sign in the middle and two terms, we can take the square root of the first piece and the square root of the second piece and go like that, and then have a plus and a minus, and it's that simple. Alright, so the answer to number 2 is going to be just as easy. We can go x plus 4 and x minus 4. Alright, now there's a problem with number 3. If you notice, we have a plus sign in the middle. That means that it's going to be prime. And it's that simple. Alright, number 4. Alright, number 4 isn't any different. Okay, we are going to take the square root of the first piece, which is going to be 3x minus 5 squared, which is going to give me 3x plus 5. 3x minus 5. Alright, now don't overgeneralize this. The only way this works is if we have two terms, both of which are perfect squares. Alright, now number 5, we got 2n squared minus 3 squared, which is going to be 2n plus 3, 2n minus 3. Last piece here is going to be 5x squared minus 3y squared. And that's going to be 5x plus 3y, 5x minus 3y. And there we have it. It's that simple. Alright? Now, the next piece down here towards the bottom, okay? My numbers 9 and 10 are a little bit different. Let me go ahead and fix that. It's going to be n squared, 7n squared plus 10n plus 3. And this one's supposed to be 4b squared minus 43b plus 63. Alright, so on number 7, alright, since that one has a leading coefficient of 1, what we can do is we can go negative 16 and factor it. 1, 16, 2, 8, and 4 and 4. We need two things that will combine to give me 6. I see 2 and 8 giving me that possibility. Now, if I have a negative 2 plus 8, that would be positive 6. That's what I'm looking for, and that's what I'm going to use. I'm going to go n minus 2, n plus 8. And it's that simple, alright? I have a leading coefficient of 1 on 8 as well. So I can just factor negative 24. And I can go 1 and 24, 2 and 12, 3 and 8, and 4 and 6. There's the ones I'm looking for. So I need negative 2. So that's going to be positive 4 minus 6. That equals negative 2. And that's going to be v plus 4, v minus 6. And there it is. It's that easy. Alright. Now, number 9, things get a little bit complicated because we don't have a coefficient of 1 on the front there. But what we can do is we can go ahead and multiply the first number times the last number. Alright? And that would give us 21. That's going to be 1 and 21, 3 and 7. 3 and 7 will give us 10. Positive 3 plus positive 7 equals 10. So that's going to be 7n squared plus 3n plus 7n plus 3. Alright, and then the next thing, we've got n on the outside of 7n plus 3, because I factored out an n on that first piece, and I factor out a 1 on the second piece, and it's going to give me 7n plus 3. So my final answer is going to be n plus 1 and 7n plus 3. Same concept goes down here for number 10. Alright, we can go and multiply the first number by the last number, which is going to be 4 times 63, which is 252. Whenever I do that, I wind up with a bunch of potential numbers here. I've got 1 times 252, 2 times 126, and I can keep going and going and going, but I know that I'm just going to have 7 times 36. That's going to be the one that I'm going to use, okay? There's more here. I'm just kind of skipping a little bit. So we got 4b squared minus 36b minus 7b plus 63. I'm going to go ahead and section this off a little bit here. Alright, in this first section I can pull out a 4b. That's going to leave me with b minus 9. On the second section, I'm going to pull out a negative 7. That's going to give me b minus 9. So my final answer here is going to be 4b minus 7 and b minus 9. And there we have it. That is a solid answer. Alright. Now, number 11 and 12. It says to factor the perfect square trinomials. If you look at those, the square root of 25 is 5. Multiply 5 by negative 2 and you get negative 10. So what we can do there is we can actually shortcut the whole thing and go r minus 5, r minus 5, which is the same thing as saying r minus 5 squared. Alright? We can do pretty much the same thing on 12. The only difference is that we have a plus sign here. So what it's going to wind up being is m plus 3, m plus 3, which is the same thing as saying m plus 3 squared. Alright? Pretty simple so far. Alright, last 4 problems. This next little section, 13 and 14, ask us to solve these by grouping. Okay, now if you remember, we had just started doing a little bit of grouping on those other 2 problems. So, grouping, all it is we group 2 sets together. Okay, in this first section, we can factor out an a squared. And that would give us 7a plus 8. In the second section, we can pull out a negative 2. And that would give us 7a plus 8. Now, whenever we wind up with the same thing in both of those parentheses, it means that we're moving in the right direction. So we've got a squared minus 2. And then we've got 7a plus 8. And that is our answer. Number 14. Same exact method, okay? We're going to go like this, section it off. Alright, Now, in this first section, we can pull out a 2m squared. And that's going to give us m plus 5. In the second section here, we've already got m plus 5. So we're just going to pull out a plus 1, and it's going to give me m plus 5. And then right here we got 2m squared plus 1. And then we've got m plus 5. And there it is. That's an answer. Alright. Last questions. It says to factor completely. Numbers 15 and 16. Real simple, no big deal. We've got 2x squared minus 15x plus 7. So, again, we're going to multiply this first number by the last number. That's going to give me 14. That's going to be 1 and 14, 2 and 7. Now, the only thing that I can get 15 out of is 1 and 14. The only way I can get negative 15 out of that is to go negative and negative. So, negative 15. So, we're going to have 2x squared minus x minus 14x plus 7. In the first section, I'm going to pull out an x. So it's going to be x on the outside of 2x minus 1. And then on the second section, I'm going to pull out a negative 2. So I'm going to go like that and have let me pull out a 7 instead. Oops. Because 2 doesn't go into 7. What am I thinking? Alright, so we're going to pull out negative 7 instead, and that's going to be 2x minus 1. There we go. So now I have the same thing on both of these. And what that means is I can write x minus 7 and 2x minus 1. And there we have it. Now, number 6, we're going to do pretty much the exact same thing that we've been doing. Alright, we're going to go 3 times negative 4. That's going to be negative 12. Alright, so that means that I can go 1 and 12, 2 and 6, 3 and 4. The only way I can get 11 is with those two. And in order to get a positive 11, that means I'm going to have negative 1, positive 12, so that's 11. And that's going to be 3x squared minus x plus 12x minus 4. Section it off. And out of this first section, I can pull an x. So that's going to be x on the outside of 3x minus 1. On the second section, I can pull out a negative 4. Or I can pull out, let's go with a positive 4, rather. That's going to be 3x minus 1, which is going to give me x plus 4 and 3x minus 1. And that's done.